In this video tutorial, we will look at properties of logarithms to expand and condense them. Because logarithms are exponents, make a big circle around that. When we're working with logs, logs are exponents. Whenever we're dealing with logs, we're dealing with an exponent. So all the rules of exponents apply. So you can derive the properties of logarithms from the properties of exponents. Let's look at the product property of logarithms. Remember that to multiply powers with the same base, you add the exponents. So if we have b to the m times b to the n, we end up with b to the m plus n. We add the exponents. If you write the equations like b to the m equals v, so if I take b to the m, I get a value v, and if I take b to the n and get a value w, then using the log, we can take this and write it as log base b of v equals m, because we said logs equal exponents. And we have log base b of w equals n, based on this. Since log base b of v and log base b of w represent m and n, when we multiply powers, we add exponents. This would mean that when we multiply VW, we add the exponent m plus n, which really are log base b of v and log base b of w, when we have log base b of vw. Therefore, when we expand the log, so if we have log base b of v times w, we get log base b of v, that's the exponent for the v piece, plus the log base b of w. So this part is the m, and this part is the n when we multiply two things together. Okay, so then we can remember that you can reverse the property, so we can condense the log. So if we start with log base b of v plus a log base b of w, we know that we're adding one exponent to the next exponent. That must mean that we are multiplying the values together. The next one we have is, if we have product, we probably have quotient. So quotient means to divide. So in the same respect, we have, if I have b to the m divided by b to the n, that really gives me b to the m minus n. So we subtract the exponents. So if I have log base b of v over w, would have us subtract the exponent. So the log is the exponent, so then we would take log base b of v, because that's one exponent, and subtract log base b of w, because that would be the other exponent. Therefore, we expand the log. If we have a log base b of v over w, expanded means a little bit longer, so log base b of v, and when we divide, we subtract, so log base b of w. Remember that we can reverse the property, so we can condense. So if you see log base b of v minus log base b of w, they can be condensed to be log base b. Since we subtract the exponents, we divide the powers. The next is if we have a power property. So if we have a power raised to a power, right, that's a power property, we're going to do that for logarithms. So similarly, when you have b to the m, and that's raised to the n, we really have b to the m times n. And you multiply those exponents. In the case of log base b of v to the e power, log base b of v represents an exponent, and so does e, so they are power to a power. In this case, we multiply log base b of v and e. Therefore, we expand the log, so we have a log base b of v raised to the e power. That would mean that we would have e times the log b of v, because remember, log b of v is an exponent, and if it's raised to an exponent, we multiply them together. So we can also say that if we have an exponent times the log b of v, that condensed would be log base b of v, and then the e would be our exponent. Okay, let's try a couple examples. So in the first one, we have log base 3 of u times v, so that would give us a log base 3 of u plus, because we're adding exponents, log base 3 of v. Go ahead, pause the video, and try number 2. For number 2, I end up with a log, and the base is 10, and we don't write the 10 because that is a common logarithm, so we don't have the base, but it is 10. So we have log of m plus the log of n. So that's the exponent added to the exponent. Go ahead and try number 3 for homework tonight. Let's go ahead and look at number 4. So we have the quotient. So we know if we're dividing powers, we subtract the exponents, and since the logs are exponents, we take the log base 3 of u and we subtract the log base 3 of v, because we're subtracting the exponents when we're dividing. So go ahead, pause the video, try number 5. Okay, so we're dividing m and n. We know that this is log base 10, we just don't write it, so it's a log base 10, it's really kind of there, it's just invisible, of m minus the log of n. And then you're going to go ahead and try number 6 at home tonight on your own. Let's go ahead and look at the power property. The power property is if we have an exponent raised to an exponent, then we multiply. So log base 3 of u is one exponent that is raised to the 8th power. So in this case, 8 is the exponent times log base 3 of u is the other exponent. Go ahead and pause the video, try number 8. Number 8 was a little bit tricky because we don't really have an exponent written. So let's go ahead and convert that to log base 10, we just don't write it, of m. But then what's the exponent for m? M is really to the first, and it's out of 3. So this becomes the 1/3 power. So if we rewrite that, that is the exponent 1/3 times log of m. Go ahead and do number 9 for homework tonight. Bring it in on our next class period. And we look at number 10. 10 combines them all together. So it's not just multiplication, division, and it's not just raised to exponents. So we're going to take each separately. So let's start out with, we have division and we have multiplication. So when I'm multiplying on the top, I have log base 3 of u to the 5th. That's one piece of the multiplication. And then we're adding, because these two things on the top are being added. So we add log base 3 of v to the 7th. Right? We have multiplication on the top, and then we have division by w to the 9th. So that's a minus log base 3 of w to the 9th. That's a log, not a bog. And then we can go back and look at the power property. So we have u to the 5th, v to the 7th, and w to the 9th. So we're going to go back and write 5 times log 3 of u plus, we're going to multiply 7 times log 3 of v, and then we're going to subtract 9 as the exponent times log 3 of w. Go ahead and pause the video and try number 11. So number 11, we have multiplication on the top, m to the 8th times n to the 2nd. So we have log, it's base 10, but we don't write it, m to the 8th plus a log n squared. And then we're dividing by log p to the 3x plus 2. Then we're going to go ahead and work with the powers. So I'm going to kind of write it down here so we can see it. 8 is the exponent, so it's exponent times the log m, which is an exponent itself, plus 2 is the exponent, so 2 times the log of n, and then minus 3x plus 2 is the exponent, and we know that 3x plus 2 has to stick together, and then multiply that times the log of p. And there's your final answer. Go ahead and do number 12 and bring it into class next time. Let's take a look now at condensing. So that was expanding. Let's take a look at condensing.